Hello, I thought I'd cover a little bit about C pointers and variables. With C being quite a low-level language, the pointers are somewhat akin to addressing modes in the assembly language. They kind of map quite nicely to it, and I suspect it was designed that way, so it will quite come in handy later on when we talk about the addressing modes within the 6502. Within high-level languages, a lot of high-level languages have a commonality in the fact that you can assign values to variables, and in this case we've assigned the value of 26 to variable 1, and the variable 2 has a value of 19 assigned to it. In a compiled language, it's down to the compiler then to decide what it's going to do with that. And what happens is the variables are given a location in memory, so the compiler puts some sort of arbitrary location, memory location, and assigns the variables to that. So in our case, variable 1 has been assigned the memory location of 02, and variable 2 has been assigned the memory location of 03. So we knew that variable 1 has the value of 26 and that variable 2 has the value of 19. And variable 1 and variable 2 can't move. They can never change from memory location 2 and memory location 3 for the duration of the program. So while this program is running, they're fixed entities. They can't. These variables never change. The values can change, so we can change that value to 3, 19, 28. Whatever value we like within the bounds of what that variable is. But the actual location of the variable doesn't move. A pointer, on the other hand, is a flexible kind of beastie, because what the pointer does is, if we take this here, where it says pointer 1 equals ampersand variable 1, well, the ampersand means address of. So what happens is that pointer then points to, and the compiler again has made an arbitrary choice and said, well, pointer 1, we're giving it address 7. So that address doesn't change within the memory, but what the pointer is pointing to can change. And what the pointer points to is the memory address 2, 02. So this here sets that pointer to point to the memory address of that variable. The next one, now this one is what in C is called dereferencing, and that asterisk means don't play with the pointer, but play with the contents of what the pointer is pointing to. In assembly language, it's kind of like indirect addressing, but again, don't worry too much about that. We'll talk about that later. But what that says is, take the address that the pointer is pointing to, then change the contents to this value. So I'll take the address which the pointer is pointing to, and then I will change the contents to this value. And as a consequence, now variable 1, if you were to do a print on variable 1, for example, variable 1 would now give you the value of 21, because that reference there changes the contents of where variable 1 is located. This next line here says pointer 3 equals the address of function 1. Well, again, it's down to the compiler to make an arbitrary choice. In this particular case, the compiler has decided that function 1 resides at location 200. In fact, that's wrong, but it's only me being picky, because you can't return an integer value from a void function, so I'll change that. What that then means there is that we have said to pointer 3, okay, pointer 3, you are now pointing at function 1, and function 1 resides at address 200. Now, if you think about it, function 1 is a fixed entity. Function 2 is a fixed entity. You can't change it. And under normal circumstances in most programs, to call it, when you call a subroutine or you call a function, you have to call it by name. But in this instance, we can call it by pointer. And the nice thing is, we can come along later on as we do, and we can change that. But in the meantime, what we're doing is we're saying pointer 2 equals the address of pointer 1. Now, pointer 2 is what's called a pointer to a pointer, because it's got 2 asterisks there. And what pointer 2 does is pointer 2 comes along and points to the address of pointer 1, and pointer 1 is at address 7. Now, on first sight, you might think, well, oh, that's not very useful, but it is. And you can use that for pointing to, multiple strings, multiple character strings, or sort of multiple integers and things like that. And you can manipulate all the pointers in a particular way, so that the actual contents of the memory, so if memory address 2 and 3 don't move, but the pointer could point to something else. And you can, it's quite flexible. It's a difficult concept to get in a very basic video, so we will not go any further with it, but this is just how they work. Now on this last demonstration, this last example, pointer 3 is now being pointed at function 2. Oops, and function 2 is down here, and now that now points to the address 492. And simply by moving that pointer, we've now completely changed what it does. And as long as these functions here have exactly the same formats, so they both return an integer and they both don't accept any values. If we changed it so that they did accept a value, for example, this wanted a value of a character coming in, then we would have to change this one to do exactly the same thing, because if we didn't, this pointer move would be invalid, because we declare the pointer to be of a specific type, and the way we do that, and we did that in the last video, was we say what is the function returning, the fact that it's a pointer to the function, okay, and the fact that it's a function. Now this is one of those peculiarities within C, and it basically, you use parens, or sometimes people call them brackets or parentheses, to like you do in mathematics. So for example, x equals x times 3 plus 2 would do x times 3 first and then plus 2. But if you wanted to do something different, you would do x times 3 plus 2. And that is precisely what those brackets are doing. They're basically taking that asterisk there and these parens, and they're actually putting them in functionally the correct order, the same as what brackets do within a mathematical expression. So just to prove a point, if we rewrite that as that, what that tells the compiler to do is, I am a function, a static function, but what I'm doing is I'm returning a pointer to an integer, rather than I am a pointer to a function and I am returning an integer. So that is the biggest difference with this. Hopefully that cleared up a little bit about pointers. Well, I might do another one later on, because the things like pointers to pointers and dereferencing, specifically dereferencing pointers to pointers, is a convoluted subject within C because of the syntax. But within our program, we did exactly the same thing here. We basically took, in this case it's an array of pointers, but again that's just taking the pointer to another step, to an array, and I may cover that again in a later video if anybody is interested. But in this but for this very, very basic video, I just wanted to put together an overview of the fact that a variable is a static entity within memory. A pointer can point to any other part of memory it likes. We can have pointers pointing to pointers and pointers pointing to functions. There can be arrays of pointers, which we haven't covered, and there can be pointers to arrays of pointers and all sorts of other things. And in reality, as I said before, the concept is not very difficult. The syntax is the awkward thing.